Hi, good morning, everybody. Thank you for joining us. I've looked at some of the names on the attendee list, and some of you are familiar faces. Some of the others are joining us for the first time. So I just want to say thank you for everybody joining us today. My name is Chris Steele. I'm one of our outside sales managers here, and on behalf of everyone at Technics, I do want to welcome you to joining us for our digital trade show with today's focus on advanced milling methods. Just like a traditional trade show, we tend this to be a platform to provide a forum for you to interface with our experts in the building and in our industry, namely your Technics sales representatives. During the presentation, I'm going to encourage any of you to ask questions, seek information on specific applications, gain knowledge on how our solutions can help improve productivity, tool life, reduce rework, reduce scrap, and just basically save money in your production process. There's a chat feature on the middle right-hand side of your screen. If this window is not visible, just float your cursor over to the green tab at the top of your screen. You can also send an email to info@technicsusa.com. We'll respond to your questions during or shortly after the show. I'd say probably after the show, just trying to make sure everything is taken care of for this presentation while we're live. If you miss any part of the trade show, you can view the recorded version by going to our website and clicking on Digital Trade Show, and link on our homepage, technicsusa.com. And we'll just be happy to have you check that out later if there's other people in your offices or at your shops that'd like to do that. So without further ado, we're going to try and keep today to 20 minutes or less. Share with you the things that might be helpful, and then you can go on to get on with the rest of your day. Today's topic, advanced milling methods, and more specifically, just emerging tool holder technology for the next generation of CNC milling. As all of you know, advancements in machine tool technology, programming technology, and cutting tool technology are as fast as they've ever been. And for the component that Technics really excels at, that holder connection between the machine tools and the cutting tools, we're just going to talk about a couple of ways you can look at kind of existing technology in your shop, as well as technology that maybe not all of you are very familiar with. So let's move on to the next slide. As we do with any of our in-person presentations, whether it's at a trade show, a sales meeting, some educational stuff at machine shops, we do a lot of those. It's all about profits and productivity. If we can't show you a way today to think about how to make more parts faster and how to make more profits with that productivity, then we need to fine-tune what we're talking about. But anytime we're speaking, we're always focusing on profits and productivity. The best part about today's presentation, these are all changes you can implement right now. So standard technology is just upgrading existing Technics tooling. And again, as today's focus is on milling, we're going to show you how you can go faster with milling with some of the tooling you already own in your shop or your customers already have in their shops. Premium technology, there's some shops that have that. Those are the fun opportunities to kind of really take milling to the next level. The shops that have that technology that we'll specify later, they see immediate gains. Once they're into that technology, they stick with it. And some other shops that either haven't been introduced to some premium technology or they have the tooling present, sometimes they need a little bit of help on how to utilize it better and apply it better. And then the emerging technology, that's probably for most of you that have tuned in why you want to be here. You want to see what's new, the latest, the greatest, so you can take that out into the shop floor, out into the field to your customer shops. And it's just going to speak about innovative milling tool holders. We encourage, for a quick spin, if you want to place an order, we have the 100% satisfaction guaranteed here. We encourage guaranteed tests. We just encourage orders. We'll always make it right and help you make the most of those advanced machine tools, those advanced cutting tools. We break down our approach to like the standard technologies that shops have already into two types of categories. There's a very different set of challenges that come up for small shank tooling as opposed to medium and large shank tooling. In the small shank tooling arena, probably the most critical item that we get the most questions and most need for application advice on is concentricity. You're running those high RPMs, you're running with smaller tolerances, you're running with less margin for error because parts are so small, the shanks are so small. And when we talk about concentricity with our customers that call in, it's usually shank grip is the first place that we're trying to help them make some improvements. Cutting tool slippage. The cutting tool manufacturers today are increasingly coming up with new and improved coatings, and they really don't pay as much attention to how those coatings affect the shank, and more specifically, the implications of shank slippage when you're in a holder. So it's one of the first questions we ask if a customer is having slippage issues. Surface finish quality for small shank tooling, whether those cuts and that milling is either on a small part or a large part with detailed finish work required, the deflection factor really affects surface quality, surface finish quality, more than any of the other factors listed here. So that's what we think about and the challenges to meet in kind of those current and common milling applications. So how do we deal with that? Well, in our small shank solutions, the power-coated collet nut, since day one, the Technics started about 16 years ago. Every single ER holder that we've ever produced has what we call the power-coated collet nut included. Quite simply, most collet nuts in the industry have steel threads exposed, and that metal-on-metal contact threaded onto an ER holder, it does the trick, but when you're finishing off the torque spec, it can cause collet distortion by dragging the head of the collet. So what the power coat nut does is we coat the threads. When you're tightening it down, it's a smoother finish when you drive the collet deeper into the pocket of an ER holder. When you drive the collet deeper, you're increasing the shank grip. When you improve the grip, you're more concentric. And when you're more concentric, your tool life is greatly improved. It also helps with deflection. When you have less deflection, the implication of deflection is most commonly played out as surface finish issues, and that's really where the power coat nut can help with small shank applications. When we talk about that power coat nut, that's something that a lot of you that again are familiar with us on the attendance list today know that we talk about a lot, and that's the adjustable torque wrench. Anytime I walk into a shop, the first thing I'm looking for out of the corner of my eye, whether we're helping somebody make the most out of an application or dealing with any production issues, is there are they using a hammer, or are they using a cheater bar, or are they using both? Because nothing will totally negate all the benefits of a collet chuck faster than over torquing a collet. So that's why we love to talk about the torque wrench. There's a real nice demo that yours truly here did on our website and our video library, doing a very quick 2.5-minute power-coated collet nut demonstration. I'd encourage all of you to take a look at it. It's something for those of you that are using things like iPads and other smart devices. You can show your customers. We always have that lag time in our visits to shops. Again, it's just 2.5 minutes. It completely demonstrates all the benefits of power coat nut, especially in small shank milling applications. The DNA collets, those are design that Technics promotes. We have in our catalog in the collet section. DNA collets are specifically designed to deal with small shank tooling for high precision milling. They are completely compatible with any ER16 collet chuck that's on the market, whether it's Technics brand name or one of our competitors. The reason why we think of these collets as opposed to standard ER16 collets is that the OD taper on the DNA collets and the counterbore design on the collets just allow these to be driven deeper into the collet pocket. There's also a finer ID line to just more accurately grab the shank. It's an excellent solution for small shanks. If you're having a customer that's having trouble with things like concentricity, surface finish, and so on, I really encourage you to either contact your distributor or just give us a call. We'll help you technically through the solution and work on getting some in your hands. This is a common slide that we do in our in-person presentations using today the power-coated collet nut. It's kind of a grip it and rip it. It's just a visual representation of what we've been speaking about. The middle nut, the bearing nut style, that's not as prominent in the industry anymore. You find that sometimes in like the woodworking and composite arena more so than the metal. And we have attendees in both arenas today. That standard, industry standard nut at the bottom showing you the holding power compared to a power coat nut at the top. Again, it's an excellent slide as a reminder to go check out our power coat collet nut demo in our video library online. This is a quick graph. Gehring did a study probably 10 or 15 years ago as well about showing that for every 10th improvement in run out, you're going to get about 10% better tool life. There's not a lot of shops that have the time to monitor that have a lot of time to track that. But the person at a shop that most definitely sees that is the person that writes the check every month for the perishable cutting tool bill. That 10% savings is a conservative number, but it's real. And again, when we talk to the medium-sized shops, small to medium-sized shops where there's still a familiar face that is the ownership, it's something that comes up every time. Moving on to like the second category, the premium technology. The challenges we see with shops that are now using more like medium and large shank tooling. By far, it could have been the only item on this panel is cutting tool pull-out. It's the biggest challenge, especially in some aerospace accounts and some medical accounts. In those applications, you have some very high-tech machinery, some very high-tech software that are just pushing the limits of both cutting tools and holders, just pushing them beyond the threshold that sometimes they're designed for. It's kind of surprising, too, how operators, programmers, machinists are surprised to learn that that's caused by the high helix geometry. And some of our solutions in the next slide and some later slides deal with that specifically. We have a couple of ways in our emerging section to completely eliminate tool pull-out, whether you're using ER collet chucks or shrink fit, either way. With today's aggressive single-pass programming, you have a lot of applications where a programmer or an operator or a machinist they've just purchased or have access to a very high spindle, latest and greatest RPM machine tool. They want to do a lot of single-pass programming, and that's completely understandable. We have some of our, solutions that either accommodate that or make it a more feasible pursuit. And then vibration and spindle wear, those shanks are like 1 inch and above. You have inch and a quarter, inch and a half in some oil field places like Houston and Edmonton. You have 2-inch shanks that are milling some awesome amount of material, but that vibration and spindle wear is a significant factor, and that's what some of our solutions deal with. So, Technics medium and large shank solutions. Two main categories that we advise our customers on. One being milling chucks. Probably the most measurable improvement with milling chucks is that they have 4 times the holding power of collet chucks. You have less moving parts. You have a larger by design, bulkier nut. You have a needle bearing cage design. You just have a lot of mass there to really clamp down on a shank. Another application where we really encourage shops to try and take advantage of milling chucks, to kind of take the collet chuck idea to the next level, is direct shank insertion. When you take a 3/4 inch, inch and a quarter shank and go right into a milling chuck that's designed for a lot of heavy removal, getting rid of a milling chuck collet or eliminating that 1 or 2 extra components of the collet chuck is pretty significant. Again, fewer assembly components that we're just talking about. Another application arena that has just become so much more prominent in general machining altogether are coolant options, and in milling chucks, it's the same. We have through tool end mills that are frequently in milling chucks. Something we advise our clients about, or customers about, is surround coolant, where we can seal on a shank to drive coolant through a coolant through cutting tool. That's one way to do it. That's through tool. Or we use like the nut and disc system that probably some of you are familiar with, where you take a solid end mill, you have a disc that wraps around it, but you oversize it on purpose. You drive coolant around the shank instead of through the tool. And it helps shops that are kind of budget conscious. I know all of them are, but some that just don't have the opportunity to invest in coolant through tooling, take a solid tool and make it coolant-ish. In a milling chuck, when milling large shanks, it's a pretty cool application, again, on the website and in the catalog. Our second premium technology solution for medium and large shank milling applications, ShrinkFit. ShrinkFit, about 3 or 4 years ago, was something that we would get a lot of questions at IMTS, East Tech, West Tech, online, on the phone, a lot of arenas. And now, ShrinkFit is just a much more common discussion topic that a lot of shops are increasingly familiar with. It has unmatched shank gripping pressure. There's nothing like it. It's able to take its TIR, it's got a 1/10 ID run out or better, and it's a single piece design. It's got on-size bores, single piece design, cutting tool goes in, and it makes those stacked run out issues with other technologies like Collet chucks marginal. Tool life savings with ShrinkFit is off the chart. It's a lot of fun, and again, if you're that person writing that check at the end of the month for perishable tooling, I guarantee you're going to be happier. This is a quick slide, just giving you a little bit of a visual representation of the improvements that ShrinkFit brings. On the left side, rigidity in the cut. We really focus on what happens when you're actually cutting chips instead of what's measured on a presetter. A Collet chuck up top versus a ShrinkFit tool down below, submitted to the same tool cycle, the same amount of cutting. Excuse me. Shows the difference that you're going to see with ShrinkFit tooling. You can't see that as often as you can with just the improvements in your final inspections. And on the right side, we talk about premature fretting. The pressures that you put on the spindle and on the tool holder are going to result in fretting over time. With ShrinkFit, it's not so much about the fact that you're reducing fretting on the holders. It's the fact that you're reducing that pressure and that stress on your spindle, the obviously more expensive component. When you have one-size tooling, you have single-piece tooling. When you're putting the side and deflection pressures of milling into play, when you're doing that with a more concentric solid design, you're going to eliminate the amount of tool tip fracturing and premature fretting and spindle pressure. However, there are caveats with ShrinkFit, and these are surprising caveats when it comes to what shops hear and what distributors hear, what factory reps hear. The high flux geometry that is prominent in high precision, high speed milling applications still poses a significant pull-out threat, even though ShrinkFit is unmatched in that shank grip category. Aggressive feed rates are really pushing the limits of the deflection threshold. Some places believe that you can do whatever you want with ShrinkFit, and there is still going to be deflection that comes into play with some of the speeds and feeds that are being programmed. And again, another limitation of ShrinkFit, that positive lock, side lock sense of security found in end mill holders, it's not available in the current ShrinkFit technology on the market. There are some shops that are still trying to do finish passes with end mill holders. They're the most functional and the right application for more like roughing applications, the right tool for roughing applications. They're not so much the best application for finish pass work, but it's what some machinists will do because of that fear of shank pull-out. So moving on to some of the challenges in the high precision milling applications. We see this in like aerospace, medical, chemical, those fields, you know, that are dealing with exotic materials, which is just another code word for expensive materials. It's where it's really critical to be trying to limit things like tool slippage, shank pullout, deflection. In those industries, you know, we're all familiar with the fact that the surface finish quality is probably under more scrutiny there than if you're doing some more traditional or standard machining and milling. And in these industries, which are very, you know, have a lot of engineering involved and a lot of programming involved, they're really pushing the limits of RPMs of the machine tool, feed rates, and for tool holder specific, it's the depth of cut that becomes the biggest factor. That's the challenge in high-speed machining when it comes to holding shanks. So what do we do about it? Well, we have some high-precision solutions. These are what we're most excited about. We debuted these ideas at IMTS. We had been testing them for over a year out in the field. We have those in our current catalog. They are definitely featured in our website, in our you know, latest and greatest section. And it's something we're talking about today. We talk about it at all our shows, and that is that we have a way to 100% eliminate tool pullout. We have a way to 100% eliminate tool slippage. That's what we call the Technics Power Lock and the Technics Shrink Lock system. The Technics Power Lock. The Technics Power Lock, as you can see in the view on the bottom right, that's a square shank indexable end mill. You can see that on the second from the left, and what we do is we take that. It's an index or a insert tipped indexable end mill. It's got a square at the bottom. You can see that where it's almost mating with the collet, and we use the component that's closest to the collet chuck. That is what we call a power lock square shank ER adapter. How does it work? You simply take the square shank power lock indexable end mill, use it as a driver for the adapter, and you can insert that adapter into any Technics ER 32, 40, or 50 collet chuck that we've ever made. It threads right in. It establishes a place for the square of the indexable end mill to be inserted. And then you're going to assemble everything just like you would a regular collet chuck. You're going to get all those advantages of driving a power coat nut onto a Technics standard ER collet chuck. And now you've essentially turned your ER collet chuck into an end mill, a milling chuck. Here's a panel just kind of recapping some of the benefits. It completely locks the cutting tool shank into an ER holder. And slippage is a huge issue with ER holders, and this completely eliminates that. Like we mentioned, it turns an Technics ER holder into a virtual milling chuck, because now you are either on center, you're concentric, you have just some unmatched rigidity in the ER holder arena to really just go after some heavy, moderate to heavy milling. And it's definitely more accurate than end mill holders. You have a slide lock there. End mill holders by design, no matter who you get them from, they're not as balanced. You can't run them at as high of RPMs as you can ER holders or milling chucks or shrink bit holders. But by turning an ER higher balanced tool holder into a end mill or a milling chuck, you can just you can have a lot more fun with that than you could with an ER or an end mill holder. The second way that we like to deal with some emerging technology for milling applications, what we call shrink lock, and featured at IMTS in our catalog on our website. We simply take that power lock square shank indexable end mill and put it into a shrink lock square shank shrink fit holder. And you're basically doing the same as you did in the previous application, except we've broached a square and a shrink fit holder. So now not only are you getting that unmatched grip with shrink fit holders, but you're also getting it with the square shank feature. And now, as we discussed, you've completely eliminated, we'll move on to the next slide, you've completely eliminated slippage and pull-out problems that you have with some traditional shrink fit applications. That middle point, that added security of a square that completely prevents tool pull-out, that is what makes an operator, a machinist, a programmer happy when they're making a cut. That's what makes the owner of a business or the managers of a production shop happy when it comes to pushing parts out the door. That security that you get with an end mill holder with a side lock screw, you're doing that same feature here, but with all the benefits, that unmatched concentricity, grip, and rigidity of shrink fit. You know, we talk about scrap a lot, and I think the bigger issue on the mind of a shop is really rework. When you scrap a part, you know that you did it right away, but when you have issues like concentricity, shank slippage, and things like that, it's that rework that you really can't detect until you've blasted through a handful of parts. That's where the feature of the shrink lock really pays off. This panel here is just some highlights, just a synopsis of some of the benefits of power lock and shrink fit. Again, the security, there's no pull-out risk, and that's just the same as you get with side lock end mill holders, especially when you're doing some aggressive milling. The concentricity, whether you're centered with the ER adapter or you're centered with the broach square in the bottom of the shrink fit holder, that concentricity elevates the run-out capabilities and the run-out features of both those types of holders. They're balanced, a feature that you really don't get as much out of an end mill holder, traditional end mill holder. They're balanced when using the Technics ER and shrink fit tooling, all certified, individually certified holders for that high balance. Simple, just a few parts to turn an ER holder into a power lock ER holder, and the indexable power lock end mills are available to go right into shrink lock holders as well. Patented, the design part of being patented, that's fun for us. The quality part of being patented, that's fun for you. You just know that the same quality you're getting with Technics ER holders, Technics shrink fit holders, you're getting it with the power lock and the shrink lock system. And it's an emerging technology. It is definitely the leading edge of innovation with holders. It's something you can walk into a shop for either demonstration purposes or, like we said, encourage your customers to consider an order or a test. But it's definitely the latest and greatest. It's a way to prevent slippage. It's a way to prevent shank pull-out. So let's cut some chips. Profit and productivity. The benefits are immediate. They're accessible to you now using that standard, premium, and emerging technologies that all provide very measurable improvements when milling. You can go faster, higher quality, better surface finish, and make more parts out the door. And that's what all this is about. So I just want to keep it short. Just want to say thank you for tuning in. You can email us at info@technicsusa.com if you want more information. One of our digital trade show moderators here, we're going to be in touch with you as well as your questions have come in. And all the resources that you're very familiar with, website, catalog, local distribution, manufacturers' representatives, and the phones here at Technics answered 100% live all day, every day. We're here to help. So thanks for tuning in. I'm going to go through about 2 or 3 questions here that came in during the discussion. We had a question from Bill. His question was, can my solid carbide cutting tools be utilized in Technics power lock and shrink lock holders? The answer is yes. We have been working with some cutting tool manufacturers to integrate their cutting tools with our power lock and shrink lock system. The process we've been going through there is just simply contacting the cutting tool manufacturers. For those of you out there, either contacting your local factory rep or just helping us get in touch with the factory itself. That's the way that we've been able to work on some of those ideas. We have customers that are doing that in the field, so we're very familiar with the process, and we'd be eager to work with the cutting tool manufacturers that you're using to apply that to the power lock and shrink lock system. Second question came in from Jeff. The Nexus inserts inside the Technics catalog, can they be used in shrink lock holders? The answer is yes. Those of you that went to IMTS, for those of you that have browsed the website, those of you that have the catalog, our Nexus tooling section, indexable insert tooling, those inserts can be used with the power lock indexable end mill, and that's what we use to demonstrate to customers how that works in the power lock and shrink lock systems. The next step there is we have Nexus cutting tool managers here that are our national staff, and they're very accessible. We have Nexus technical managers on staff, and they work with you to kind of engineer a solution there and work with the Nexus inserts on the power lock and shrink lock indexable end mill. And the last question from Sarah, will the power lock adapter spin out of the ER holder? No, it will not. We designed the power lock adapter to be using the end mill as a driver with left-handed threads, so that when you're doing right-handed spinning in machine tools, it's actually going to make that connection tighter. So we often get the same question when it comes to collet nuts. We do make left-handed collet nuts for those that occasional spindle that's spinning in a non-traditional direction, and it's just that same concept in theory going into the power lock ER adapter as far as spinning into the holder, into the collet chucks. With that, I'll conclude. Again, thank you for joining us. This discussion will be archived on the website, and everybody have a great day, and let's go cut some chips.